Hi guys, it's Eric here. I hope you have a nice day. So today's daily question is very simple, as well as this week's daily weekly contest. I just finished it an hour before, and I aced all the questions in like 25 minutes. So I mean, compared to the last week's contest, that was too hard for me. So anyway, let's take a look at this today's daily question. Find a unique integer sum up to 0. Given an integer m, return any array containing a unique integer such that they add up to 0. Okay, so for today's daily question, I think the example here is very bad for me to understand because at first attempt I think this question is too complicated for me because you can see that he got an input integer is 5, right? So we need to output five elements to form a list that form an array that the elements in the array that sum up to 0. So I saw the output here like -7, -1, 1, 3. -7, -1, 1, 3, 4. I think, what the fuck is this? It's like just a random and with no order here. I mean, they are all random orders, and I cannot see the patterns of the array. So I think this question, wow, this question is only 1,167 points for real, bro. And I took a look at the second example here. Like, okay, so I thought it is too hard. So let's open the auto draw for our analyze. So in this problem, I think we shouldn't be confused by the sample outputs like here, right? The requirement is simple. We just need any unique integers whose sum is 0. Okay, by the way, we need to avoid this situation like if you input n equals 5, you cannot output 5 0 because 5 0 are the same integers, not unique integers, right? So let's take a look at this here. So if you think carefully, like n equals 5, right? So if you do not look at these examples here, whenever we want numbers to add up to 0, our first idea must be using opposite numbers, right? Like if I want to output, if I want you to find two integers that add up to 0, it must be opposite numbers, like himself and itself and its negative, right? 1 and a negative 1. If three numbers, we just need 1, -1, and what? And the 0, right? Because 0 is not the same as 1 and -1. So for the five numbers, we just need to find what? 2, -2, 1, -1, and 0, right? So you can say well, what we find the integer here is use the m floor divided by 2, right? If we do this calculation here, we will get 2, and we will get minus 2 here. So um, the range for our search is very clear here, right? So if n is even here, is very straightforward. We just need to take n floor divided by 2 pairs of opposite numbers, and if n is odd, we first take those pairs, and at the end we simply add a 0. That gives us exactly n numbers, all unique, and they will definitely sum to 0. And since the problem doesn't care about the order of the output, we don't worry about the sorting here, as I mentioned before, like this one here. So that's all. Once we see the symmetry, the construction is very easy, right? So let's start coding here. So according to our thoughts, I think the code is very simple. We're gonna need a result to store our final list here for I in range 1 to n floor divided by 2 plus 1. Our result append Append what? Append this I, right? And we need to append what? Okay, I'm sorry. I misinput a space here. We need to input its negative, not right? Rest dot append negative I. And we're gonna judge if the number is e odd number. Our result append a 0. And we're gonna return our result. Very simple, right? Because we just don't we just remember that we don't need to confuse by the output here. He said he wrote the output here to confuse you deliberately, I think, because if he said this -2, -1, 0, or 1, 2, it's very, very simple, too simple, right? So let's run our code. Okay, it's accept all the test cases. Okay, so we beat our opponent by 100%. So in this question, I think we need to consider if we encounter some questions like he want to us to add up to something to 0, we need to consider the symmetry and the opposite number to make our question much more simple here. So I think today's question is very simple, and I hope you guys have a nice day. Bye bye.